Hi, everyone. My name is Reefa McDoom. I'm a restorative dental hygienist. And today I'm going to talk to you a little bit about restorative. I have actually had the pleasure of visiting Uganda 3 times. And the most recent time I was there with Dr. Barzilay and the Build Your Smile Foundation. So this beautiful picture was taken there. And it was an absolutely fantastic outreach. And today, I'm going to talk to you a little bit about restorative, and we're going to be speaking about from prep to polymerization. That is the name of my little lecture, and let us begin. So our topics today are going to be design and preparation. There's a pretty interesting difference between the design of a prep for an amalgam versus the design of a prep for a composite restoration. We're going to talk a little bit about that. We're going to talk about glass ionomers, composite resins, curing lights, and then a little bit of the future, which is class 2 composite restoration. So when we think about the design and prep for an amalgam restoration, we're looking at adequate depth, because that's what's going to give your filling strength. We want a flat pulpal floor. We want right angles. So we like geometry. This is where geometry is fun in dentistry. We want a lot of right angles. If you look at the diagram, you'll see from the occlusal view, there aren't a lot of right angles because we don't want that on your cavo surfaces. But if you look at the mesial view and the facial view, there's steps and a lot of right angles. So we want the proximal axial walls at right angles to the pulpal floor. So right angles are a good thing. So buccal and lingual walls roughly approaching 90 degrees to the tooth surface. You're going to see this in a couple of slides a little bit more clearly. But what we're looking at is we're trying to create retention to lock in that amalgam restorations. We want undercuts in the dentin. We want slots in the floor of the prep. We want internal boxes, and you can see those here. And so the enamel walls of this prep should follow the direction of the enamel rods. The enamel rods must be supported by dentin. And so if these two things are not in play, or either one of them are not in play, with any type of occlusal forces, there will be chipping and fracturing. The margin of the gingival seat of the proximal box should be apical to the contact area. You do not want to have your margin at the interproximal area. There's movement there, it will wear away. And your cavity prep must be designed to protect both the restoration and the tooth from applied forces. And remember too, that we need at least 2 millimeters in depth to withstand occlusal forces for an amalgam. So here we have a good look at occlusal convergence. So the wall of this prep, roughly 90 degrees, that's what I was referring to. And you're looking at 2 to 5 degrees of occlusal convergence. So essentially you're looking at that which is at the depth of the prep being a little bit wider than the cervical aspect of the prep. So Y greater than X. And this is what creates the occlusal lock. Now, in the way of, if amalgam is your only choice of restorative material, well, okay, we then have to find other ways to lock in amalgam restorations as we drift further toward the midline, so in the way of bicuspids. So this dovetail idea of preps essentially allows for the locking in, the mechanical locking in of this amalgam. And of course, we would be mindful to try to work as much as possible from the lingual aspect of these teeth as the preparation allows. So this is a good illustration of the difference between preparation style. You can see again the convergence on the left-hand side with the amalgam. But you can see what the composite looks like. So the composite, now you have a much smaller opening. The pulpal floor is not flat. On the diagram to the right, if you look at the solid geometric line, that is the preparation for your amalgam. So a little bit further, that which is outlined in white, not the dotted line, that would be your preparation for composite restoration. So much more conservative a prep, and we don't have right angles. So let's talk a little bit about glass ionomers. So we're not going to talk about the entire history of these materials. They are tried, tested, and true, first introduced to North America in 1972. So these guys take a little while to work, to get into play. They need 3 to 6 minutes before they really start to set, and you can't really polish them until a good 8 minutes in. That said, the maturation begins in about 24 hours, and it continues for a lengthy duration. There's a very slow and gradual setting of that. So this has poor tensile strength, so it can't be used in the occlusal surfaces. You should not use this for incisors. And when you're mixing this, it's important to note that any type of moisture contamination will weaken this material, and it will render it with less integrity. I believe you use Fuji 9, and that is a very good material. So there's a rechargeable fluoride component to glass ionomers. So what does that mean? You're looking at the release, which happens initially and ongoing, but it's able to promote tooth remineralization as well as inhibit tooth demineralization because of the slow leaching out of the fluoride. This is actually a fantastic quality. It has good bonding strength to enamel and dentin. It is biocompatible. The body doesn't mind it. Good insulation, low shrinkage usually with the self-cured version. So that is the mixing. And particularly good for root caries for obvious reasons. And composite resins can be placed comfortably over these. If bondability is a word, these two things sit and layer very nicely the composite onto the glass ionomer. And it is also a very, very versatile cement. Versatile properties. Basically, you know, you use it for orthodontic treatments, but in the you use it for restorative treatments, but in the orthodontic world, well, a wonderful strong chemical bond occurs between a metal bracket, and the enamel with these glass ionomers. You know, when it comes to Pitt and Fisher sealants, well, you know, if there is, don't wait until there's extensive decay. You know, drill out, do what you have to do to follow those pits and fissures, and then mix your glass ionomer to a more liquidy consistency and just fissure it right into those little nooks and crevices. And it's fantastic because you're going to decrease caries manifestation simply by placing that there and avoid a much larger restoration in the future. It does protect the pulp quite well as a liner, and there continues to be versions of this, just different forms, including of restoration material, including glass ionomers. So these are kind of interesting. So a resin modified glass ionomer has the characteristics of both. So you're looking pretty much at half composite resin and half glass ionomer. So this is amazing. It has all these terrific properties that we talk about. It bonds to the tooth, and there's fluoride release, there's biocompatibility, except now you have a composite in there, and so you can polish it up beautifully. It's a little bit stronger. So altogether, a very, very nice material. Compomers have been around for a little while, and this is essentially a composite resin which has a little bit of fluoride in it. It has just minute traces of glass ionomer properties, primarily a little bit of fluoride. And then we have gymers, and these two have been around for a little while. This is a resin base and a pre-reacted glass ionomer technology. So as far as the gymers go, they are not as strong as a resin modified glass ionomer. People do use them today. They're strong enough to be used in North America for posterior composites in primary dentition. So let's talk about composite resins. So composite resin is an aesthetic restorative material. It has an organic resin polymer matrix. It has inorganic filler particles, which is what gives it its strength. And it has a coupling agent, which holds everything together. So again, we're not going to detail the history of it, but the take home from this slide is the fact that they've been around since the 1960s, adaptic and concise. These were chemically cured, self-cured composites. And as time, let's say, drift forward 2 decades and a little bit more, in 1986, something called heliomolar, a reinforced microfill, came to be, and that was revolutionary because it was strong enough to be used in the posterior part of the mouth, and it polished up really well. So it had the aesthetics quite well. So it had the aesthetics component as well. Now, by the 1990s, we had microhybrids. So these guys, these guys are essentially what you're looking at is good physical properties, good finishing, polishing, all of those things a whole lot better than your heliomolar. And the hybrid aspect of this has to do with more than one type and size of filler particles. And they're usually made of glass and silica. Shift forward again another 10 years and we're looking at nanohybrids in the 2000s. So now we're looking at 2 or more types of fibers in the matrix. So in an ideal world, a nanohybrid, you're looking at multiple sizes of particles in the filler and multiple types of filaments within the matrix, and you're looking at a very strong composite. And you are also looking at something that holds up beautifully aesthetically. So Percolite Ultra, which is what you're looking at here, this is nanohybrid technology. This is what we use, and to boot, it is radio opaque. So when you place these, you can see these on x-rays. And of course, we have a couple of delivery systems. We have the syringes, which are age old, and the unidoses, which require a dispensing gun. We use the unidoses. And in the way of classifying the curing modes, polymerizing of composites, we have chemical cure, we have light cure, and we have dual cure. So self-chemical cured composite resins. Now we can write an entire essay about these things, but I'm just going to give you the very basics of them for today. We have limited time. So they are chemically activated, as a self-explanatory, which means you're mixing a base and a catalyst to activate, to create this chemical polymerization. These guys require a fair bit of time. So you've got to isolate the area. We talked a little bit about that 8 minutes before you really want to leave it alone. So now you've got to isolate that. If a person is a mouth breather, you know, the moisture can get in there. Not ideal. The dual cure, on the other hand, well, as one reads, I mean, it's a combination of self and light cure ingredients and activators. So this is, you're going to need your light for this one. So chemical, yes, this is happening as you speak, but you can cure that as well with your light. Now, the curing is assured, which is a really good component of this, because you've got both methods happening. And it is ideal for deep preps when you can't get your light in there, when you just simply can't irradiate, if you can't just get your light in there to cure something that is exclusively light cured. So light cured composite resins. So this is the process that uses blue, a visible light, to activate the chemical, the photo initiator that sets off the polymerization. So these guys now are relatively easy to use. You place them, there's no mixing, you have control. You decide when you want your composite to set. And unless you take a very long time, you have plenty of working time. There are different shades. There are different shades of composites, as we know, and different shades will cure at different speeds. So increasing your curing time, for instance, for a darker shade of composite would be wise. We've learned this over time. And a cured shade of composite may be different from an uncured shade of composite. So if I have and aesthetic restoration. And I'm going to get out, I'm going to match a shade as best as I can visually, and I'm going to get out a little ball of that, and I'm going to place it in that area, and I'm going to look at it. And if it looks good, then I'm going to cure it. And once I cure it, you'd be surprised. Sometimes you get the shade that you're expecting. Sometimes you don't. Sometimes you want to modify. You want to go back and maybe change your shade. And of course, with the light cure, we need eye protection. Now, what tends to hold things together? I love this stuff. These are flowable composites. So flowable, why? They have a runnier consistency. Why? Because they have more resin matrix and less fill. So these guys are great. They get into tricky areas, into undercut areas. They're wonderful for repairing things. When I create a posterior composite, like a class 2 composite on a molar, we have to place increments. You can't bulk fill these things. And so I use just a tiny smear of the flowable composite in between each increment, just to try to avoid voids. This is self-leveling as well. It's viscous, but it's self-leveling. So we all know now that the prep for a composite is not going to have a flat pulpal floor. It could be there could be undulations and little crevices. So this is a really great thing. It actually levels it out for you, thereby creating an environment which is ready to receive the composite. One would never exceed, of course, the 2 millimeters depth of cure, and that is very important when it comes to this. And simply because it has a lot of resin matrix. And these, of course, are not for use in areas withstanding forces. Any area requiring compressive strength, you would not use this. So there's some really great advantages to composite resins. I mean, we all understand the tooth preservation now, because we're losing less of the tooth. You're bonding directly to tooth structure. There's no mechanical retention. So the prep just has to be the size of the prep, the size of decay. So much more tooth preservation. We have adhesion to tooth structure, more so in the way of enamel. We have excellent aesthetics. We know this. We have adequate durability, low chemical conductivity. So you're not going to have that temperature sensitivity that you would get with a large amalgam restoration. Easily repaired. You don't have to remove the whole composite. What you do is just, detail what it is that you need to repair and just add to it because you can. Biocompatibility, the body seems to like it, and it does not contain mercury. Furthermore, in the way of disadvantages, and this is one that we really do need to think about, this is polymerisation shrinkage. So what this is, you probably know this, but just to review, when you place an increment of composite onto tooth structure and you put a light on it, the composite wants to pull toward the light. So it grabs the tooth structure and it pulls, and in doing so, fractures in the enamel, little cracks in the enamel, and they have never really nailed this down. No one will ever say this is an absolute, this absolutely happens, but they certainly believe that it does happen, and they believe it enough so that we do implement systems to account for this. Composite resins are also technique sensitive. There are many, many steps, and we have to keep it dry. You don't have, the moisture that amalgams will accommodate. Amalgams will allow you to work with a little bit of that. That is not a possibility if you want a proper bond with composites. They require proper curing technique. So we're going to talk a little bit about that. You don't just put your light on it. There are ways to do that. And they are less durable and resistant to wear versus amalgam and ceramics. So we also have more incidence of secondary caries versus amalgam. And a lot of times this happens in the proximal box. This is class 2 restorations on posteriors. You see some recurring decay on x-rays. The BIS-GMA washes away over time, opening up the margin. We get a little bit of bacteria in there, a little bit of decay starting, and we have to get in there and remove that. You see that a lot more with composites than you do with amalgam. They bond well to enamel, but they don't bond as well to dentin and to cementum. And they don't have the antibacterial properties that you would have with an amalgam restoration. We also get a little bit of postoperative sensitivity with the composite restorations, large composite restorations. It does happen. I use a desensitizer called G5. It is a glutaraldehyde-based desensitizer. It's a liquid. I use a microbrush. I get in there when there's a lot of dentin exposure, when you have a large pulp chamber. Either of those two things or both of those two things, you can pretty much expect postoperative sensitivity unless you're very, very careful. My G5 has worked very, very well. And composites are a little bit more expensive. They themselves are more expensive. You also need a light, and the light has to be maintained. And so the last slide, when it comes to composites, the technique is very, very important. Layering is a very important thing. And layering for an interior, well, we have dentin shades and enamel shades of composites. And we have an opacity and a translucency of teeth. So we would use a dentin shade perhaps first to mimic the opacity of your dentin, and then use a composite resin, which is a little more translucent, to mimic your enamel. It's actually quite amazing. You wouldn't be able to tell sometimes. We can actually accomplish some really, really good things. The bottom image is the layering that one would expect in the way of a posterior composite. Now, if you look at it, you'll see these little triangles. So we call this the tulip technique. And so the tulip, the leaves, the petals are little triangles. And what are we trying to do here? We're, of course, putting smaller increments. We only have 2 millimeters. We can't exceed that because we have depth of cure to think about. We also want to consider what it is we're touching. We're going back to polymerization shrinkage. So we want to touch 1 wall, maximum 2 walls, but we can't bulk fill this, or there would be a significant amount of shrinkage. Now, there are bulk filled composites. We're not going to talk about those today. This is what's tried, tested, and true. Curing lights. So let's talk a little bit about these guys. So this is a dental instrument that's capable of generating and transmitting a high intensity blue light currently. The original curing light from back in the 1970s, the very first one made by LD Kolk and Company, was a UV. So because it was a UV, an ultraviolet light curing system, it came with all the harmful effects with the ultraviolet. It had radiation, it was carcinogenic, people's eyes were profoundly affected, and it also had limited depth of cure. So these guys are what's available today. We have quartz tungsten halogen. Those are your halogens, very, very popular. The light emitting diodes are LEDs. These guys cure most composites. They're a moderate fast cure. Your halogens will cure pretty much all composites, and that's a gradual cure. Plasma arc curing lights and argon lasers are both available. They're much less common. They're both very expensive. The first having a very fast cure, the second one a moderately fast cure. We're going to talk about halogens and LEDs. So your halogens, basically your halogen light consists of a quartz bulb with a tungsten filament in a halogen gas environment. So these were the old bulky, clunky lights, the guns. You know, there were the cord attaching to the wall, and then you had the cord attaching to the unit. They were very noisy. There was a, you know, they ran hot. It was in the infrared range, so you needed a fan. So the fan was constantly going. So they were very loud as well. So you know, it didn't sound very good, but what it does have, which is very, very important, is the broad spectrum wavelength of light that it emits. So what that means is it cures most bonding materials. So therefore, it's most likely compatible with your material. The LEDs run on a battery charge, so you've got no cord. These are sleek. These guys, everybody loved them. There was far less heat and noise than the halogens. Low power consumption and long service life, so they were ideal. They last a really long time. They didn't take up all of your power. However, they had a more specific wavelength than the halogen lights. So what does that mean? So the most popular, these guys are the most popular light today. However, newer curable materials have photoinitiators designed to respond to just a narrow range of light. So think about that, the light wavelength. So you have to consider then what your light is and what your material is. So with a more specific wavelength, the options of what you can cure becomes more limited, which is the case in the first and second generation LEDs. Of course, time drifts forward and companies got a little bit smarter. So manufacturers decided to modify the lights to emit multiple wavelengths. So the polywave LED providing broader scope to cure any type of composite. And polymerization. Essentially, you're looking at a zipper type of reaction. Initially, this type of molecular enmeshing happens very, very quickly, and then slowly it lessens. So molecules are never completely cured. At best, you're going to get about 85%, and you can never overcure. But that being said, we don't want to overheat while curing. So yes, recommended, go back in there, cure, but be mindful of the soft tissue, be mindful of that pulp. Irradiance is the light output of a curing light. So this is very important because we need to know what our light is doing. So this is the power output per surface area at the curing tip. And this varies between 600 to 2400 milliwatts per square centimeter. Now, most dentists in North America look for about 1,000 milliwatts per centimeter square. So the higher the output, the faster the cure. Now, the higher the output, the greater the depth of cure they think, but they're not quite sure about this as yet. Now, depth of cure is a very important thing, and we're going to talk a little bit about that because your depth, what is it? Essentially, you're looking at the distance from your light to the composite resin. So light scatter and absorption reduces the power density and the depth. So if you look at this, you're looking right down the center of this. The degree of conversion at the base of this down 5 millimeters is only about 15%. And look at the shape of the cure. It's a bit of an arc. So practically speaking, the depth limit is about 2 to 3 millimeters. So the light tip must be placed directly on the restoration for maximum cure, for the broadest cure. You don't want it tipped, you don't want it on an angle. And this is significant when we're talking about posterior restorations. You probably tend to not see it. You tend to not see it as much when it comes to, you don't see it as much when it comes to your anteriors, although you can have large anterior restorations. But when it comes to the posteriors, we really have to be mindful of this. Sometimes, even when I'm done and I've taken off everything, I've prepped, I've just trimmed everything, I'll go back and I'll cure again, being very mindful of the pulp. And so we must maintain this light. So a periodic visual inspection of the unit is important. We want to look at the light guide, the filters, the bulbs, and every one of these guys comes with the manufacturer's recommendations. Please read them and know them because it's crucial to the life of your unit as well as how well this unit is operating. And this is what we use in order to test to make sure our light is doing the right thing. We need something called a radiometer. And there are different kinds. You can see them at the bottom of this slide. They're separate units. There are radiometers that come attached to the unit. It's actually on the base. We use something called checkup, and that's us right there on the right-hand side, making sure our units are doing what they're supposed to do. And we also want to be mindful of the tip, the light tip. If it's dirty, your light tip will shorten the bulb life and you will have an increased heat buildup. And being mindful too of the fact that when you do get your radiometer, there are light specific ones. You have halogen radiometers and LED radiometers. Okay, class 2 composite restorations into the future. So this is a little look ahead. And so we look pretty much for all the things that you would look for in the way of an amalgam, with a few exceptions. You know, we're going to think about how we're going to finish these, because we're going to need burrs to do that. We now have to use an adhesive system. We have to find the right one, something that's going to create adequate adhesion. That's a very crucial part of your restoration. And the depth, you know, where are you working? How are you going to get your light back there? Your matrix system, how are you going to isolate this in order to keep it dry and give you enough time to place this filling? And your placement technique is very important, and of course, occlusion. So we know that we have a more conservative prep than amalgams. We know we're more technique sensitive than amalgams. Difficult is a good proximal contact. So when you use a Toffelmeier matrix system, often the contacts with composites end up cervically. They don't end up where you get a nice contact, you know, a very natural contact between the teeth. And you want that contact, that interproximal contact, to be where it needs to be for the life of that tooth, for the patient to be able to take care of that tooth, to floss, etc. So we use two. We use the V3 system, and we use the Toffelmeier matrix system. You know the Toffelmeier, probably less familiar with the Triodent V3 sectional matrix system. So you look at this guy. It's a complete kit. You have a nice forceps, which is used to place the ring. We have tweezers to manipulate the matrices as well as the wedges. And we have these. We have the V3 rings. So that's the green and the yellow. They're two different sizes, green a little bit bigger than the yellow. And you choose the one that works for you. Now this is the star of the show here, because when you're creating a wall with a Toffelmeier, your wooden wedge is what's separating the teeth. Well, that's not the case here. The wedge in this diagram is exclusively used. It's used for two things. It's used to snug up that sectional matrix to the tooth to create a good seal. And it's used to saddle the V3 ring on. So you see on both sides, the V3 ring is sitting on this wedge. So your nickel titanium V3 ring has a very good spring strength, and it creates the elasticity. It actually pushes the teeth apart. There's enough force there for tooth separation. And so this is what is creating the separation between your teeth, and this is what allows us to get a nice contact. You burnish that, you get a nice contact, and if you look at these sectionals, they're actually shaped like teeth. They're rounded, they're curved, they're much more natural looking than a Toffelmeier, a flat Toffelmeier. You get a good illustration of that right here. From the above view, you can see that with the Toffelmeier. That's a nice flat interproximal. You see the wedge there, and you get a really good picture of your V3 ring, which looks like this. You can configure them in different ways. You can layer them. They take a little while. You have to play with them and get used to them, but they are absolutely wonderful. Here we have two sectional bands and we have two V3 rings in order to create the MOD on this premolar. And look at the picture on the right. I mean, that is an absolutely spectacular filling. You know, you wouldn't know it. You match the shade well, and you really work at those interproximals, and you can have an absolutely beautiful filling. Which brings me to my last slide, which is all about, well, equally as important as the placement of your restoration is the finishing of your restoration. So it's crucial if you're hoping to have a restoration which is going to last, you have to finish. You want those margins as smooth as possible, and that requires time. Usually by the time we get to this stage, we're trying to wrap up our appointment, and this is not the place to cut corners, be it your aesthetic burrs, your discs, very, very important. So on behalf of the Build Your Smile Foundation, I hope this was useful. Thank you for spending your Saturday with us.